Hey everyone, welcome to the next video in the GameAudio Tech Tips. Today we're going to take our audio spline that we built in our last video and we're going to refactor this into C++. With that being said, I just want to be clear that I'm not a programmer. I'm a technical sound designer and I'm still learning C++ myself, so there may be things that aren't 100% correct, and there may be things that are not ideal, whatever. Like, I'm just trying to go through that journey with everyone else and share my learnings, and just take something quite simple. Like we obviously made this spline as a basic spline anyway. Obviously the intention here is for people to build on this. This isn't a complete spline, it's just the kind of starting place for a spline to start having things built onto it. But with that being said, we're going to take this to C++, and yeah, just go through that journey together and think about how we can use this to then maybe refactor some of your own stuff as well, and just start that journey of code. And then also probably going to look into insights as well, and doing like a comparison of the blueprint function and then the C++ function, and just seeing if there's any difference there, because that stuff's always interesting anyway. And yeah, it just kind of helps us make arguments on whether we should do it or not anyway. So yeah, with that being said, let's get started. Actually, one thing I want to say as well is, like I said, I'm not a programmer, so the environment that I'm using here is just, it took me actually hours to get Visual Studio working in the past, and it still works now, luckily. But if you require any like support with Visual Studio, like not compiling or anything like that, then you might have to reach out to like the Epic forums or somewhere else to find those answers, because unfortunately I'm not going to be able to give you them. So this is just assuming that you have, in my case, I'm using Visual Studio, and I am using the hot reload feature in it, the live coding stuff. So just bear in mind you might have a different process of compiling your work than I will be doing. So yeah, let's get started then. Okay, on to the next section then. So we actually need to make our C++ class, and we can do that from Unreal. Before we do that though, just make sure that the URL set that you have here is not the same name as AudioSpline. So this one is called BP_AudioSpline, and that's okay for us. And we are going to make this an actor. So let's go ahead and call this AudioSpline. And I would always recommend putting things in folders and organizing them as best you can. Obviously, you don't want to go too overkill with that. But anytime I've tried to do that in this environment, it breaks. So I'm just going to put it in my root folder and let this do its thing. Okay, so that's finished now, and it's now opened up Visual Studio for us if it wasn't already open, and it's generated our files, reload, and it's added it to our project. So if we go to C++ classes now, we should be able to see our audio spline. I've got a copy one here, which is one I made before, which I'm just using to reference between. So yeah, if you see the AudioSpline copy, just ignore that one for now as best you can. So first thing that we want to do then is, just to keep it simple, and actually what we should have done anyway is just make this into a function. And we're just going to call this one BP_main. And the reason for this is our C++ file is going to have a function called main in it, so we can't call this function the same thing. And yeah, like I said, this is a refactor, and what we're going to try and do is we're going to try and replicate step by step each section of this, and we're going to literally do that step by step together. just to make it a bit more so we can absorb that information as a bit easier. And then also we can kind of call our main C++ function here, and we can bounce between them and just be double sure that everything we're doing is accurate. And again, like, this is a simple blueprint, so what we're going to do here, it's safe to work in that way. If you've got a more complex blueprint, you might want to make a new class and then build it up gradually, rather than doing what we're doing now and just reparenting the whole thing. So just bear that in mind. Okay, so we're going to go to class settings then, and we're going to override this parent class into an AudioSpline. So what that means is our blueprint actor here now, it's not a its parent class is no longer an actor. Its parent class is now looking for the AudioSpline C++ class. And what that means is any functions that we now write in C++ will be exposed to us on this blueprint, which is good. So the first thing that we want to just establish here is this is a spline, and right now we have a spline here, and this is just a component that's made from the blueprint. So the first thing that we're going to want to do is make a spline that lives in C++, and then that way we can more easily call functions on that spline that we're going to need to use in our C++ file as well. Okay then, so on with the C++ header file. One thing we need to do first is make a spline variable. So we're going to go ahead and actually do that in another section here, just so it's separate from our things over here. And we're going to make a U property, and we're going to have this set as edit anywhere blueprint read write. And the reason for the read and write is just in case we want to do anything with that in blueprint. And then next we're going to add a U line component, and this is an actor, so it's this star here is making sure that we're aware that it's pointed to an actor, and we're going to go ahead and call it the variable spline. And one thing that's screaming at us is use spline component. It doesn't have a clue what that is. So what we need to do is we need to make sure that we add the include for this, which is now added it here. However, one more thing that we need to do is just make sure that we end that there, and we need to make sure that this include file is actually the one at the bottom. The generated.h should be the last include in the file, otherwise when we try and compile it might make some it might complain to us about that. So what I'm going to do first is, now that we've added this header file, to the header file, I'm just going to go ahead and make sure that we can compile. So we're going to do this often to make sure that we're not jumping into any issues. Because if we do this more often than not, we can make more sense of if things are going wrong or not. And again, like I said, this is more very much beginner tutorial on taking some refactors into code. So just bear that in mind. So yes, we have our header file there then. So the next step is to actually have it as part of our actor. Okay, so now that we have our header file done, let's go ahead and create this into our C++ file as well. So one thing, we need to make this link here essentially. So we're going to say that our spline, because the spline variable here is pointing to this uSpline component that we have on our header file. And one thing we need to do is create default sub object. Now what this is going to do is it's actually going to make sure that it adds it to our actor, because otherwise we just have a reference that doesn't do anything. anything that's useful for us. We need to be able to actually see it and interact with it. And we just want this to be called Spline. Save the file and let's compile again. Okay, now that's compiled, we can so what's this saying to us? There's already a spline. Is that what that's okay? Target must have a connection. Okay, so what's happened there is we've now made a spline in C++. We can see that. But some of our old functions now are broken. So we're just going to go through and hook these references up. And then our blueprint should hopefully now compile. There we go. So this is what I mean. We're kind of slowly rebuilding our blueprint up into separate pieces. And yeah, let's just make sure that it works. So because we have a new spline, we just need to make sure as well that the spline actor is a bit more what we expect to see. And back to our blueprint then. Yeah, so we can see then since our last video, it's still doing the same stuff that we want. It's just instead of having a blueprint spline, it's the actual spline itself is one that's made in C++ for us. So yeah, the next step then is we want to start building up our little stages here of what we're doing. So the first thing we're going to look at is setting the character location. Okay then, so now we want to make a new property. Cannot spell. And this time we're just going to go for edit anywhere. And this is going to be an F vector. I'm going to call this player location. And we're going to make sure that we give it some default values and close that off. And next, we're going to make a function now in our header file, blueprint callable. And the reason we're doing this as blueprint callable is we're going to use the we're going to call this from blueprint. We're not going to run it on tick. And the reason for that is because we're going to do our comparison and insights if we have the time to do that. So rather than run one on tick and one on in C++, one in blueprint, it's just a bit of a better, fairer example of running them both through blueprint. And then of course you're more than welcome to run that in native if you want to. Okay, and this is going to tell us that we haven't made our function usable yet, so we'll do that as well next. Next up, underneath our void tick, we're gonna start to build in our function. So audio line and main. So what we're doing here is we're gonna build this function in our file so that we can call it in blueprint. So the way that this works is void essentially means there's no output pin, so it's not going to return anything for us, such as a float value or anything like that. It's just going to be a kind of a typical. In fact, it's going to look exactly like this. It doesn't return a value. And then this is our class AudioSpline, and then this symbol here, these two colons, is basically it's letting us know that we can look into that class and then look for the main function. That's essentially how that's made up there. So what we want to do is we essentially need to make sure that we are setting this player location because that's what we're going to need, right, in comparison to our blueprint. So player location, and we're going to say get world, and on get world, we're going to run get first player controller, and from there we're going to get pawn, because obviously pawns are controllable, and from there we're gonna get actor location. So essentially what we've done here is we're rebuilding our blueprint. So when we set character location, in this case I've just called it player location, this is the node set player location. That's what we're doing here. Okay, now we're requesting where does that come from, which is get actor location from the player character. So essentially what we're doing is we're just reconstructing this. Okay, that's exactly what we're doing. This function itself might be a bit different to what happens in Blueprint, but it's achieving the same thing for us. And to confirm that we're doing, to confirm what we're doing is true, we can also draw some debug. So let's go ahead and draw debug sphere and get world again, as we've just done. And we're gonna pass in our player location because we're using this here. Okay. And in terms of the sphere, we're gonna give it some properties. So we're gonna have a size of 10, sorry, radius of 10, 12 segments, and we're gonna need an F color. In this case, you all know by now I like to use purple. And then just some other stuff here. We're going to make sure it's drawn every frame and close that off. And I'm just going to do a little comment here saying confirm player location works. And when we save this, now that we've saved this page, this function now is not complaining anymore with the squiggly lines. So now let's jump back to Unreal and just click live coding and just pray that everything is fine and dandy. Okay, so live coding succeeded. Awesome. So now if we go to our event graph, we should be able to here now say main, and here is our function. So this is the function that now comes from our C++ class, right? So what we can now do is just, for example, if we just unhook that and then run our function now and click play, we can see that our debug here is drawing at our player location at the pelvis. So this is telling us then that the code that we just wrote is doing what we expect. It's tracking our player location just as it would our blueprint version as well. So yeah, that's step one achieved. One thing we haven't done in C++ is we haven't actually validated it, because that's a bit more of a different topic to do that. It's just, we should absolutely be doing that, because in C++, if we try and do this and it isn't valid, we're going to crash. So always make sure you do that if you can. In this case, we're not going to do that because we don't need to for this little tiny little piece of work. So the next step we're going to look at then is setting our closest location. So again, let's go back to our project. And just as we had before, we can just copy our play location. And this time we can say closest location. And you can see here that we have a function here that we do find location closest to world location. So that is what we're going to do next. Okay, so as we go, let's just do some comments. Set player location, and this time set closest location. Okay, and closest location equals spline. So this is kind of why we needed to make our spline here, because we need to be able to run this function on this. So we need to have a reference to it directly in C++. So on our spline, we want to call find location closest to world location. Okay, and if we go back to our project, we get in our character location here. So that's what we're concerned about, the character location. In this case here, we've called it player location. Player location, and if you remember, we had the enum was the coordinate space. So spline coordinate space, and we need to look inside that and set that to world, and Spline coordinate space world. There we go. Okay, and then similarly we can copy our debugging here, and in this instead we need to say closest location just double checking that looks okay, and closest location works. Okay, and we can save these, and again, I always open that wrong window there. Let's compile that. Live coding. Cool, succeeded. And let's play. Unresolved errors. What was that telling us off about? Okay, so what's happened now then is we've got variables that are the same name. So in the case of our blueprint variables, okay, yeah, this is a real bonkers what we've done now. This is a bit annoying. I should have done this ahead of time. Closest location, and then for now this is really messy. We're just going to add underscores to all of these. And instead, we're going to set via that, because we need to basically repair the damage that I've just done to our existing blueprint. Okay, we've saved our old work there. So now that our function works again, we can see now we have two debug drawers here. So one is the player or the character location. One is now the closest on the spline that we had from before. So again, you can see that these little building blocks, we are running into a few issues, obviously, like the same name variables, but you can see that we're slowly building our spline in code, which is awesome. So the next one then is we need to do is in Spline. This will be a little bit different in terms of the flow, because I always suggest using select nodes in Blueprint, because you can kind of do the whole like one line thing. So in this way, we're not going to have that same approach necessarily. We're going to start to do like nested if statements or stuff like that. So just bear that in mind for this one. Okay, so next up, we want another property. Edit anywhere. And this time, we're going to need a Boolean. And if I say is in spline equals false. Now, what it's telling us here is it's not going to break anything, but it's kind of suggesting us that it's not the right naming convention. So it's suggesting that we add a lowercase b there for whenever we use Booleans. So just bear that in mind if ever you see that. And then just as a reminder, I'm just going to drop that one away. Just as a reminder, we are running, we need to, instead of setting it straight away, we need to kind of run a branch essentially. So we're just going to say is spline. And what we're going to do is we're going to do an if and spline is closed loop. Now, if you remember, we do different things on the spline depending on if it's a closed loop or not. So for example, if our spline is a closed loop, we're gonna do some stuff depending on the right vector. Otherwise, we're gonna say that it's false. So that's what we need to build in here. So if this closed loop, we're gonna need some braces, and we're gonna need to get our dot product equals f vector dot product.
Sorry, something went wrong.
Alexa is definitely telling me something went wrong, as always.
Sorry, something went wrong.
Alexa, be quiet. So what we're rebuilding here.
Sorry, something went wrong.
I'm just going to mute that if I can. Turn it off because it never listens. Okay, that was a bit of a curveball. So anyway, yeah, what we're doing here is, like I said, we always build backwards. So we're setting some stuff here. So if we are in a closed loop, which is our current of our if statement, it's true. So we now need to return something if some other things are true or not. So what we need to do is we need to get the dot product of these two vectors to identify if we should set this to true or not. So that's what we're doing now, is we're getting our player location minus our closest location. And we're doing that via this function here. So the two inputs of our dot product is player location minus closest location, which is our first argument. And the second argument is our find right vector closest to what location. So that's what we're doing here, because this dot product takes into different vectors there. So spline, and we're gonna find right vector closest to world location, which itself takes in the character location and the same coordinate or space as before. So player location e spline coordinate space world, and we need to end there as well. Okay. Actually, that is not needed. Okay. And similarly, what can we do to confirm? That's okay. And then what we can do to confirm that is we can do a little debug print. Add on screen message debug message. We can say its key is 1. It's gonna last for 0.1 seconds. Purple. String. Printf. Text. I'll just find this stuff a nightmare to do. Dot product. And then we're going to feed it a float value. And that is going to be our product that we're going to feed into it, which is this one here. So just a little breakdown then is we're going to do our print string. So this is the equivalent of a print string in Blueprints. The key is 1, so that we don't get the whole, we don't get the same message take up the whole screen on the left side. It's just going to replace itself on each new instance. And we're just saying dot product colon, and then we're basically giving it a float value. So that's what this is. It's converting the float to the string. And essentially for each of these percent signs, these conversion signs, you need to give it an argument after the fact. So that's what this is saying. It's going to give us our dot product value as part of that string. So if we are Spline is a closed loop, we're going to do that. We need to do another if statement. Then we need to dot product is less than 0.0. Okay. Some braces, and is in Spline equals true. Else b is in Spline equals false. And then on this level here, we need to else is in Spline. Okay. So what we have here is we've essentially just recreated our stuff here. So we're checking if the closed loop is true or not. If it is, we're gonna run this stuff here. And then, so yeah, we need to check our dot product is less than 0.0, which is what this line is telling us here. If it is true, we're just going to return our Boolean value to true. Okay, so now just double check that our files are saved. Yes, they are. And then we're going to live coding now. So that was successful. So one thing we want to do is actually make sure that what we did works. So we're going to go to our spline and we're going to enable our closed loop. And we're going to add another spline point and one there as well. And let's just hope that this works. Okay, so we can see then that we're getting our dot product draw, which is the debug message saying that if it's a closed loop or not. So we can be sure then that because the closed loop is now activated, the debug message that we're asking it to draw is here. And then if we just turn off the closed loop, the debug message isn't showing. So we're on the right lines now of starting to, like, say, recreate this spline. So I'm just gonna leave that on for now, and then we can move on to the next section. Okay, so back into Visual Studio then. We need to think about, sorry, let's go back into here and emitter location. So essentially what we're doing is, depending on if the isnn't spline is true or not, we're setting our emitter location from either of these two locations here. Okay. So then let's do that. We need another if statement. So we're going to say set emitter location from is in spline. And this can be on the same, like, yeah, here we go. So if B is in spline, is in spline, there we go. We're going to say emitter location equals player location. Else emitter location equals closest location. And regardless of either of these, we can draw a debug sphere. So actually, let's just copy one that we have up here, rather than type that out again. And this time we're just going to use closest. We need to say emitter location, and let's just change the size as well, and the color from purple to orange. And let's make sure as well that we, so here again, we're just going to copy this because it's all kind of the same format. And yeah, again, let's just, as we are doing this, compile every single step. All right, and let's click play. And now then we can see our debug is updating our emitter location. And the important difference now is, if you remember the spline before, that whenever we enter the region of the spline to say we are in the spline, we are setting our emitter location to the player. And then if we're out of it, we're setting it to the closest point on the spline. So again, we're kind of using our dot product to determine our Boolean, isn't spline true or false. And then after we have that, we are using that to position our emitter location, which again, we're doing the exact same thing here. We're doing our Boolean first to determine that, and then we're setting our emitter location depending on isn't spline. So the next thing is distance to closest location. So that's what we're going to do next. Okay, then back into Visual Studio. So we need a U property. And this time we're going to have a float, and distance to closest location, and its default is going to be that. Okay. And then we need to add this after here. We're going to say distance to closest location. So distance to closest location is going to be equal to, again, let's just recap this distance vector function here, which is taking our character location and emitter location. So because this is a function that we get provided by Unreal, we can actually use this. We can use this on our, it's built into f vector. So we can actually just say f vector. And remember earlier when I said about this, these two colons, that allows us to look into functions that f vector provides for us. So in this case, we're just going to use distance, and distance is obviously asking for two arguments here, f vector v1 and f vector v2, just as we see in the blueprint. So there we go then. So we can say player location and emitter location, and we can close that. And again, just to confirm this, we can do an on-screen debug message. So we have one already here. So there we go, and we can call it purple. And instead of dot product distance, and then we're going to copy this one here. And let's just make sure that we save both these files. And now back to here. Okay, and let's have a look. So now we have our distance in the top left corner there. In fact, I did a mistake. We want to change our key from 1 because we copied it from up here. Well, let's just give it a different key so that we see both. There we go. There we go. So we get our distance and our dot product now. So yeah, so when we're outside, our dot product is obviously going to be the same as the distance, but when we go inside, where our distance is now 0 because the emitter location has been put onto the character there. So there we go. And the only difference now that we have between these two functions is this set world location. Now this sphere it lives in the blueprint. It doesn't live in the C++ function. So just to make it a bit fairer, what I'm going to do is I'm going to do that like that. So what I would like to do is just confirm then that this C++ is doing what we expect it to do. Sphere from emitter location. Okay. We need to get emitter. Emitter location needs to be blueprint. Go, and then now we should be able to get emitter location. There we go. So our C++ actor now is interacting with the sphere, as we can see, and our blueprint main function that exists on the blueprint from before is now doing the exact same thing. So we have essentially the same functionality. The only difference though is the C++ has these drawings built into the debugging. So I'm just going to comment those out for now. And then what we aren't going to do in this series is you should add this to the debug function, obviously, so that it's the same. But we're just not going to run this function though, so that essentially these two things are going to do the same thing. And then we can use insights then to check what's going on there. Okay then, so let's do some stuff with insights. So we can see then I've got the blueprint function that I'll run first, not the C++ one. And I'm just going to click play, and then we're going to start tracing. So just going to run around a little bit without being in the closed loop, and then go in the closed loop. So we want about 10 seconds. So I'll let this get to like 48. Okay. And then now we'll go into the main, and actually just going to stop that. So this session here is going to be our, this will be the blueprint one. So we can see here, that's where we were running in the game. Let's get 10 seconds of that and search for Spline. Here we go. That's that one. And then we'll look at that in a moment. And just to confirm, using the C++ one now. Okay, now we're going to do the C++ version. So same again, just run around. Just do about 10 seconds. Okay. Okay, so now that we have our insights captured, we can take a look at the main function that we were building. So in this duration of time, 10 seconds, we can see that the total MS of that was 35.4 for the blueprint main function. And then if we go to the C++ version, because we obviously were still running, that on tick from here. So the blueprint is still obviously able to visualize this for us, and it's running now at 28.2. So we can see that there's a 7, there's about 7 milliseconds difference there across the time. And then what that means is, in terms of the average time, you can kind of go into a calculator and do that, or you can just highlight over this I. And we can see here then that the average time in Blueprint is 0.029, whereas in the C++ function that we're using Blueprint still to call is using 0.023. So yeah, this is clear then that we've made our spline into C++, and it's more efficient as well for us, which is good. So yeah, well done everyone, and we might do more of this stuff in the future. It's been quite a good look into getting my hands on some C++ and also into Insight as well. So yeah, nice one. See you in the next video.